In this video, I'm going to be working through one of your problems that you'll find on your handout. So number 2 is probably the one that offers the greater opportunities of working through these problems. So one of the things when you're trying to find bond energies and determining whether or not something is endothermic or exothermic and how much energy is actually either taken into the system or released is that you have a chemical equation. In this case, my chemical equation for number 2 is C2H4 plus F2, and it provides a C2H4F2. So the first step when working through these bond energies, the key is to actually draw out your structural formulas. And the reason that you need to draw those out is you need to count on how many different types of bonds there are and how many of each of those types you have. So looking at C2H4, you notice that in the center, and it's always key to start in the center, we have a C double bonded with a C. And when I look at the top of that chart, you'll recognize that that bond will require 614 kilojoules of energy to break. So remember, breaking bonds requires energy. That means energy is coming from the system, from the surroundings and going into the system. In addition to having C double bonded with a C, we have a carbon bonded with a hydrogen. And in this case, we have one of those bonds here, one over here, one over here, and one over here. And we don't have any of those. So we have a total of 4 of those bonds. Each of those bonds requires 413 kilojoules of energy to break apart. All right, so with that said, that's a total of 1,652 kilojoules of energy. The last bond that we need to break is the fluorine with fluorine bond, and this bond requires 155 kilojoules of energy. If I add those all up, that means that it takes a total of 2,421 kilojoules of energy to break all these bonds. And remember, you need to break these bonds in order for them to rearrange themselves to form this chemical over here. When bonds are made, energy is released. Sort of see it as 2 magnets that want to come together. And if you hold 2 magnets closer together, they will naturally come together. They'll make a click, which is that release of energy, and they are stuck together. So see that as atoms as well. So same story for this one is we need to identify the different types of bonds. So I have carbon and a carbon bond. I always start with the center because these have a tendency to easily be overlooked. And that bond is going to release 348 kilojoules of energy. Then I have a carbon-hydrogen bond, and I recognize that I actually don't just have one of those. I have, in fact, still, again, like last time, 4 of those bonds. And so that means 4 times 413 kilojoules of energy is released. That's 1,652 kilojoules of energy. And then the last 2 types of bond, or the last type of bond I have is a carbon-fluorine bond. I have 2 of those. And in that case, the carbon-fluorine bond releases 485 kilojoules of energy, and I multiply that by 2 to get a value of, let's give that a try, 970 kilojoules of energy that are released, which means there is a total, in this case, of 2,970 kilojoules of energy that are released. That's when I've added all of these together. So we know 2,421 kilojoules of energy were required to break these bonds. 2,470 were released. When I look at the difference of this tells me that overall, and we call this a delta H, overall I have 594 kilojoules of energy that are released in this overall reaction. And I always signify that by a minus sign. In that case, that means 549 kilojoules of energy will be leaving the system. And that means that they're exiting the system. In this case, again, this is an exothermic reaction. So when you're working through these bond energy problems, step number one is draw the structural formula. You need to draw the structural formula because otherwise you won't know where those double bonds exist. And it's also going to be hard for you to count what types of bonds and how many you have. Then secondly, in terms of tips, start at the center. It is often that if you start on the outside, you forget this bond in the center right over here. That's this carbon-carbon bond or this carbon-carbon bond. It's just a tendency that eventually things get so messy. And then essentially remind yourself that breaking bonds requires energy, making bonds releases energy.